In a previous film, ground fog, advection fog, and low-ceiling clouds developed in related situations were illustrated. This film will continue the subject by considering upslope fog, frontal fog, and low-ceiling clouds which develop in upslope and frontal situations. Low-ceiling clouds usually allow a ceiling of several hundred feet. However, they may extend to as low as 50 feet above ground level. On the other hand, upslope and frontal fog may extend to the ground and close in an airport completely. Upslope fog will form when warm, moist air is forced up a slope by prevailing winds. The warm air mass must be stable and moving up the slope slowly. Also, the warm air must be moist enough so that its dew point is not far below the temperature of the air. As the air moves up the slope, the decreasing atmospheric pressure will cause the air to expand and cool adiabatically. If this cooling is sufficient, the temperature of the air mass will be lowered to the dew point before the ascending motion ceases. Fog will then form. However, fog will not form if surface turbulent mixing exists in the upslope movement of the moist air. With surface turbulent mixing, and the temperature and dew point still equal, low-ceiling clouds will form. These clouds may be very patchy at first, and will be identified as scud. If the cloud thickens into a solid layer, it is identified as stratus. And if the turbulent mixing is severe enough, stratocumulus clouds will form. In the Great Plains region, where there is a gentle rise toward the west, upslope fog or low-ceiling clouds frequently form when there is an east wind and the moisture content of the air is high. Along a warm front, warm air lies over a wedge of cold air. As the front moves, the warm air rises and is cooled adiabatically. Moisture condenses and clouds form. Rain falls from the clouds into the cold air below. Evaporation of the rain lowers the air temperature and raises the dew point until the air temperature and dew point coincide. Fog then forms. Since the wind velocity in a frontal area is usually above 10 knots, surface turbulent mixing will create low-ceiling clouds rather than fog. Usually these clouds are stratus type, but may be combined with scud and stratocumulus. The warm front fog may also be lifted by daytime heating. At some distance in advance of the warm front, rain may completely evaporate in upper air without reaching ground level. Under these conditions, fog will not form near the ground, but will exist as low-ceiling clouds. Over land areas, warm air following the surface position of a warm front will be moving over terrain that has been cooled by the cold air preceding the front. Let us say that the temperature of the warm air is 70 degrees Fahrenheit and the dew point 65 degrees. As the warm air mass moves over the cold terrain, it is cooled. When the temperature of the warm air lowers to the dew point, condensation takes place. With gentle winds, widespread post-frontal fog develops. A stronger wind will cause low-ceiling clouds to form. When warm front fogs or low ceilings occur, they usually cover a large area. Since warm fronts usually move slowly, these conditions persist for many hours and become a definite hazard to flight operations. Sometimes a cold front will generate a fog. However, cold front fogs are not as common as warm front fogs because surface turbulent mixing of the cold air beneath the front prevents fog formation. More common to the cold frontal conditions is the formation of low-ceiling clouds. They are caused by evaporation in the precipitation falling from the cloud shelf. When cold front fogs or low-ceiling clouds do occur, they usually do not last long since they move along with the front. Also, cold fronts generally move more rapidly than warm fronts and remain over one place for only a short time. The ground is not visible when flying above a solid layer of low-ceiling clouds. Descent is dangerous unless a sufficient ceiling is known to exist, since from above, low-ceiling clouds may have the same appearance as surface fog. If the weather officer in your pre-flight briefing has indicated any possibility of fog forming at your destination, an alternate airport will be recommended. Plan your flight so that there is sufficient fuel aboard to execute the alternate procedure. If fog prevents a landing, do not circle the field hoping the fog will lift. Your best course is to proceed immediately to the alternate airport where you can make a safe landing.